In this tutorial, we are going to train a neural network to classify a company as having low or high corruption risk, given data about tax rate, revenue, and inflation rate. Let's plot some example data points on a graph. In our setting, points colored green represent low risk, and points colored red represent high risk. Touch the plotted points with your hand to inspect them. This is a simple neural network made up of 9 neurons. The cables represent connections between the neurons. Each cable is associated with one real number. This network is untrained and all of these numbers at the moment are 0. The first layer in the network is called the input layer. Each of the neurons in this layer represents one dimension of the input. The middle layer in the network is called the hidden layer. The neurons in this layer perform mathematical transformations. The last layer in the network is called the output layer. The single neuron in this layer outputs the decision high risk or low risk. We are now going to train the network. We start by initializing the network, which will assign completely random values to all neuron connections. The network weights are now being randomized. The cable lengths change to correctly represent the new values. The network is now ready to be trained. Grab one batch of training data and place it on the hexagonal slot. This is a batch of training data. It represents a set of 3 data points, that is, 3 companies and their details. Watch the network process the inputs one by one. Depending on the input values and the weights between neurons, certain neurons light up and get activated. If enough neurons light up, the output neuron will be activated. If the output neuron activates, the network's prediction will be high risk, and otherwise, low risk. The network completed one iteration of training and is now adjusting its weights, according to the mistakes that it made. It is now time to test its performance. For this, we use a separate test set. Grab the batch of testing data and place it on the hexagonal slot. We fast forward the testing process due to the size of the test set. After the first iteration of training, the network achieved an accuracy of 61.1% on the test dataset. Continue training the network and try to achieve an accuracy of 80% or more. Congratulations, you have successfully trained the neural network to an adequate level of accuracy. This concludes the tutorial and you are now free to exit or continue trying to improve your network.